Right. The reason why liquid hydrogen is used is because hydrogen is made up of a single proton, rather than an atom, something like lead, for example, made up of 197 protons and neutrons together. So liquid hydrogen is made up of single protons, and because it's liquid, the hydrogen, the protons or hydrogen atoms are much closer together, more densely packed. So it's because they're protons is the first thing to say, and then the second thing is to say that they're more densely packed. Right, electrons have to be accelerated to very high energy, because in order for electrons to show wave-like behavior, their de Broglie wavelength must be equal roughly to the size of the objects it's interacting with. So you must therefore have a very high velocity, and if you've got a very high velocity, you therefore will have a very high energy. So the wavelength, the Broglie wavelength, has to be similar to the object it's interacting. And in order to get that, we know the object is got very, very small wavelength, so the velocity has to be very, very high in order to do that. Okay, so the de Broglie wavelength is calculated by using, which is lambda, by using h over p, which is the Planck's constant divided by the momentum. You've been told that the momentum is this here. So you substitute the values for Planck's constant, 6.63 times 10 to the negative 34, and then which will be given to you in the formula booklet. The momentum was 2.1 times 10 to the negative 18. So the answer is 3.157 times 10 to the negative 16. Quickly check that they want us to have it in two significant figures, so that rounds up to 3.2 times 10 to the negative 16 to two, that should say significant figures, SF. Okay, you need to know that the up has got a charge of plus 2/3, the down has got a charge of minus 1/3, and so if you have up, you would have 6 over 3, which of course is a charge of plus 2, 2/3 plus 2/3 plus 2/3. We'll give you 6/3, which is plus 2. Down will be 3 negative thirds, so that is a score of -1. Now you're told that antiquarks also combine to form antiparticles. So you've got an anti-up, so you've got the anti-up. So what charge will that have? Well, it'll have the exact opposite of that there, which will be -2/3. And you've got an anti-down. The line on top means it's antimatter, so it's anti-down. So its charge will be the opposite of a down, which is a third. So an anti-up, and a down is going to give you a charge of -1.